Lute is the name of a program I did to automate like visualizing scales and things on a guitar fretboard. So if I show a basic example and build it up, hopefully that'll make sense. So it's a command line program, and it takes arguments like this. So that a standard one would be a list of intervals, which is defined in numbers. So for a major scale, it's a tone, semitone, tone, and a semitone, and we define these as 2 and 1. So the numbers for how many semitones each step is, and then you have to give it a place to start, a place for the tonic note, and we define that as the fret on the lowest string of the guitar. So default, that's E. So if we want a C major scale, we just want to see that, then we give it this set of intervals and then say start on the 8th fret. So here we can see our C major scale on 12 frets of the guitar fretboard with the string names here. So N for natural. In this system it's N for natural, minus for flat, and plus for sharp. And it has a little database with some names, things like modes of the natural minor, harmonic minor, and melodic minor, and a couple of symmetric ones that we'll know the name of. Otherwise I'll just say unknown, because you could give any numbers, any set of intervals, as long as it completes in 1 octave, it's going to be able to map it. So if we want to show some variations on this and alter it a little bit, a good one we could do is just show a mode. So without changing the interval set, we can sort of rotate it to a mode using this M flag. So if we want to see natural minor Aeolian, then we do 6. So now we're looking at C Aeolian. If we want to change that to A natural minor relative, then we give it obviously 5 for the A, and now there you have that. And so one thing that's quite useful, maybe for some people, is the ability for different tuners. So you can do completely custom tuning, as many strings as you want, any note. So if we wanted, for example, like a Lenny Breau tuning with just standard and then a extra high A, you define it like this. So it's descending order, so A natural on top, and then E natural, B natural, G natural, E natural, A natural, and E natural, so just standard underneath. So now we can see it's, it's the same shape but just with this high A on top. Of course, the scale degrees are the same as the A you have on the regular guitar. So yeah, if it wasn't obvious, the numbers are just the degree of the scale. The 1 is going to be every A note in this context. If we wanted to add something on the bottom like a George Van Eps low A, you can do that as well, for example. But then if you add lower strings, be mindful that you'll need to change the starting fret, because that refers to the lowest string. So if we want this to still be an A, we'd say the 12, because that's the A note on a low A string. So there you have your 8-string guitar with your A Aeolian shown on there. So if we want to enumerate some chords and just sort of brute force some shapes out of this, what we could do is, let's go back to standard tuning. You just give this -C flag, and what that does is it's going to show every possible 4-note chord that doesn't stretch more than 4 frets. And here you can see, you'd probably write that to an out file, and then if we view that here, we can see, there's quite a few. So if you want, the various different parts of the fretboard, different shapes, it's just going to be brute force, systematic. So you could pick one for like a concept or something, maybe not that practical, just out of curiosity. So something else you can do is you can use a bit field, so like a string of trues and falses, ones and zeros, to specify whether you want to filter out certain notes. So if we have here a natural minor, which is the 6th mode of this interval set, let's say we want to make that into a minor pentatonic and get rid of certain notes. So if we just want the first, not the second, third, the fourth, the fifth, not the sixth and the seventh, it's A, this A flag for activity. So 1 is keep the note, 0 is drop it. So now we can see what we have here is, I knew that looked strange. If we start on the 5. So now here we have our, because remember when you change the low string, then you have to change the starting fret because that refers to the lowest string. So now here we have our A minor pentatonic just there, because we've filtered out these notes, and the degrees remain the same as if the rest of the notes are there. It's just kind of a visual aid. So a completely separate mode. There's it's just a concept kind of curiosity thing, probably not that practical, is if you wanted to brute force like interval permutations for a 1 octave scale of a given amount of notes. So let's say if we take a 7 note, let's say we want every possible 7 note scale that completes in 1 octave with the first note or the tonic or whatever you want to call it on the 5th fret of the lowest string. So if we do that, then we can see it's going to be, so we E for enumerate and then the number 7 notes scale we're doing, and then we're going to say start on the 5th fret. So obviously this is going to be another big output. So if we want to look at this, say look at something in the middle, then we can see a bunch of different permutations basically of just the intervals. You could maybe pick one for a concept or something. It's just very systematic brute force way of doing it. But this is just sort of a trying to demonstrate some simple concepts. That I would imagine this is quite extendable in a lot of different ways, like visually or different features. It's just written in Go, just like the standard library, no packages or anything, so it's pretty small. I'll put a link to GitHub in the description. Cheers.